All right, guys, this is the key for the Unit 4 practice test, for our practice quiz rather, 4.1 to 4.3. You have 30, we're going to start with just filling the unit circle. So again, 30, 60, 90, just count by 30, 120, 150, this is 180.
You got this.
300, 330. Okay, then we do the 45, so we're going to have 4590, this is 135, we got 225, and then we got 315 right here. Okay, then we'll do the radians. So radians again starts with 0. You got to know this is pi over 6, pi over 4, and pi over 3. And from that, we're just going to add. So pi over 6 with pi over 6, pi over 3, and then plus another pi over 6 is pi over 2. So that's 4 pi over 6 here, which is the same as 2 pi over 3, 5 pi over 6, this is pi, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, this is 3 pi over 2, this is 5 pi over 3, pi over 6, 2 pi. Okay, this is 360 degrees, and this is 2 pi. Then we've got the middle, so we got pi over 4, pi over 2, this is 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. Then we've got our trig values, so this is 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. And then we think about it, I start with this triangle. This is our long side of a 30, 60, 90, so it's going to be root 3 over 2, 1/2. And then we just fill in from there. Okay? So root 2 over 2, root 2 over 2, root 3 over 2, 1/2. This has the same height as this one, so this is root 3 over 2. And so that must be root 2 over 2, and that's 1/2. Then this is, all these cosines are negative here, all positive here, only sine is positive here. This would be 1/2, so negative 1/2, negative root 2 over 2, and negative root 3 over 2. And now at the bottom, these have the same x values, so the x values will match. Should be negative root 3 over 2, negative root 2 over 2, and negative 1/2. And then the y values are the opposite, so it's negative 1/2, negative root 2 over 2, and then negative root 3 over 2. And so the only thing positive here is tangent. And then last one, these have the same y values, so we say, I think this is negative root 3 over 2, negative root 2 over 2, and negative 1/2. And then the x value will be the opposite, so it's 1/2, root 2 over 2, and root 3 over 2. So the only thing positive here is the cosine. Okay, that's the unit circle. We're going to use that to help us answer the question. So I'm going to get this out. First thing we have is converting from degrees to radians. So to go from degrees to radians, you want to multiply by pi over 180. So just remember, okay, you go to radians, you're going to multiply by pi over 180, so you're going to get 210 pi over 18, 180, sorry. This is the same as 21 pi over 18, and that's the same as 7 pi over 6. Okay? For 13 pi over 20, we're going to multiply that by 180 over pi to get it to degrees. That makes sense because you want the pi's to cancel when you convert degrees. So we're going to get 13 times 180 over 20. Okay? It's the same as 13 times 18 over 2, which is the same as 117 degrees. So again, you get a 4-function calculator, so you can figure that out. Okay. Now we're evaluating trig values. So this is where we're going to use our unit circle. We're going to use our unit circle here. So first one, cosecant. We got to know what boys, you got to know what cosecant is. Cosecant is 1 over sine. So we're finding 1 over sine of 5 pi over 6. Well, what is sine 5 pi over 6? Well, we can use our unit circle here. Find 5 pi over 6, which is up here. Sine is 1/2. So this is the same as 1 over 1/2, which is 2, right? B tan negative pi over 3. For negative, I'm going to go back 1 pi over 3. So it's going to be negative root 3 over 2 over 1/2. That's the same as negative root.
Cookie.
Negative root 3 is your answer. Okay? For cosine 315, if that one's easy, we're just going to go to 315. Cosine is just root 2 over 2. Easy. Okay? So for secant 5 pi over 3, again, secant is 1 over cosine. So this is 1 over cosine 5 pi over 3. Just going to go to our unit circle. 5 pi over 3. Down here, cosine is 1 over 2. So this is just, again, 1 over 1 over 2, which is just 2. Okay. Cotangent 7 pi. So where is 7 pi? Well, to get 7 pi, so for 7 pi, we're rotating many times around, right? So 2 pi is this. This is one time around is 2 pi. That's 4 pi. That's 6 pi. And so 7 pi would be over here, just that pi. 7 pi equals pi. Okay. So what's cotangent of pi? That means adjacent over opposite. That means negative 1 over 0. So that's undefined. E undefined. Okay. Sine 13 pi over 2 is kind of a similar idea. This is many rotations around, because 12 pi over 2 is 6 pi. So what this means is we're going around 3 times for 6 pi. 1, 2, 3, and then what's left over is a pi over 2. And so pi over 2 is left over. That's coterminal with 13 pi over 2. So sine pi over 2 is 1. Good. All right, what angles are coterminal with 11 pi over 6? So this is saying which angles are the same. They're different numbers, but they're the same measure as 11 pi over 6. Let's think about where 11 pi over 6 is. 11 pi over 6, if we drew it out, would be over here. This is 11 pi over 6. Okay. All right. So just by looking at these, I can already eliminate some. So you think about, okay, well, 11 pi over 6 is here. Where's pi over 6? Pi over 6 is right here. Right. So there's no way pi over 6 could be on there. Whereas negative pi over 6, look, negative pi over 6 is going to be right here. That is going to work. And I'll prove why that will work in a second. No, 5 pi over 6. Well, 5 pi over 6 is like over here. That's not coterminal, so that's out. And then I'm going to prove the other ones using the coterminal features. So coterminal angles to 11 pi over 6 are going to be any angle that is plus or minus 2 pi away from 11 pi over 6. So we're just going to add 2 pi to this. So what we can do is we're going to rewrite 2 pi over 6 as plus minus 12 pi over 6. Okay, so if I ever add 12 pi over 6 or subtract 12 pi over 6 from this, that is going to be coterminal. So, for example, 11 pi over 6 plus 12 pi over 6 is 23 pi over 6. Right? Therefore, that is going to be a coterminal angle. If I subtract, I would get negative pi over 6, which we already chose. We already know that was 1. And if I subtract it again, I would get negative 13 pi over 6. So therefore, that would also work. 13 pi over 6 and 21 pi over 6 are not values that I would get when I add and subtract 12 pi over 6, so they're not going to work. Okay, so just B, F, and G. So to find coterminal angles, just add and subtract 2 pi or add and subtract 360. For which angles between 0 and 2 pi is cosine negative root 3 over 2 and tan negative root 3 over 3? For that, you're going to look at your unit circle. Okay, so some value between 0 and 2 pi where cosine is negative root 3 over 2. Well, there's only 2 values that's true for, and that's 7 pi over 6 and 5 pi over 6. These have cotangent values of negative root 3 over 2. But it's saying that tangent is also negative. So down here, we know that tangent is positive, right? That's one of the features of this corner. Because they're both negative, your tangent is going to be positive. So it must be up here at 5 pi over 6. Yeah, that makes sense to anybody. Okay, nobody's watching, but okay.
Yeah, it makes sense.
It makes sense, okay. Without a calculator, we're on the last page now. Without a calculator, put the following in order from least to greatest. So all you're doing here is you're going to evaluate them, and then we're going to order them. What is sine of 9 pi? So 9 pi, again, that's just going around 4 times. 1, 2, 3, 4. And then going, there's 1 pi left over. Okay, you're basically dividing 9 pi by 2 pi. And whatever's left over is the value we go with. So this is 8 remainder pi. You can think of it like that. Or sorry, 4 remainder pi is kind of how I'm thinking about it. So it's like 4 rotations around with a pi left over. So we're looking at this point. So what is sine here? That's just 0. Okay. Cosine 9 pi, so same value, that's negative 1. Okay. Cosine 10 pi, that would be going over here, that is 1. And then sine 11 pi over 4. 11 pi over 4 is, that's also a rotation. So we're going to do 11 pi over 4. It's over 2 pi, so we're going to subtract 8 pi over 4. We're going to get 3 pi over 4. This is really 3 pi over 4. So we go 3 pi over 4. That is over here. And that is, sine of that is root 2 over 2. That's root 2 over 2. So from least to greatest, it would be cosine 9 is number 1. Then it would be sine 9 pi. Then it would be sine 11 pi over 4. And then it would be cosine 10 pi. That would be the order from least to greatest. Okay, so you're just evaluating them using unit circle and then ordering them. Okay, last two, we got 6 and 7. Evaluate all 6 trigonometric functions for theta given that point P is the terminal sine of the angle theta. So we draw out this point. 5, negative 2 is over here. 5, negative 2, right here. 5, negative 2. Okay? And this is theta right here. Right? This is our angle. And to evaluate this, we're going to look at the reference angle right here. Okay, we're focused on this. And we're going to make a triangle. And we need to find all 6 trig functions. So that means sine, cosine, tangent, and cosecant, secant, and cotangent. Okay, so sine theta, well, we need to find this last side before we can sort of evaluate the sine, the cosine, the cosecant, and the secant. So let's do that first. We're going to use a Pythagorean theorem to find that. 5 squared plus negative 2 squared equals c squared. That's 25 plus 4 equals c squared. So c equals the square root of 29. This is the square root of 29. Okay, now I can fill everything in. Sine would be negative 2 over root 29. Cosine would be 5 over root 29. Tan would be negative 2 over 5. Cosecant theta would be just this in reverse. Root 29 over 2, negative 2 rather. Secant would be root 29 over 5, and cotangent would be 5 over negative 2. All right, for this test, I will not take off points if you don't rationalize the bottom, but in the future, we will focus more on that, okay? So it's okay if you leave it in this form, it's okay just now, but we'll focus on that in the future, okay? 7, find the remaining trigonometric functions if cotangent equals 3 over 7, but cosine is negative. It's really similar to this one, except you kind of have to figure out where the point is. You're going to draw your axes, and then you're going to ask yourself, okay, well, cosine is negative. So in which quadrants is cosine negative? These 2 quadrants. So it has to be over here somewhere, right? One of these 2. But cotangent is positive, right? So cotangent positive, that's the same as tangent being positive, right? You can think of this as like, oh, tangent, cotangent, they're positive. So if tangent's positive, that only happens down here because both values are negative. That's how you get the positive tangent. So that means that I must be in this quadrant here, quadrant 3. And then that means that since cotangent is 3 over 7, that's adjacent over opposite. This is my x and this is my y. So it should be negative 3 to the left and negative 7 down. Okay, I'm going to focus on that angle. Same as before. Now you have your point. It's the same exact steps as above here. The same steps. you are going to do Pythagorean theorem to get this here. So you're going to get 9 plus 49 equals c squared, which is 55 equals c squared. So this is root 55. And now I'm ready to go. So I'm just going to plug everything in. So I already know that cotangent theta is 3 over 7. That means that tan theta must be 7 over 3. Sine theta is going to be negative 7 over root 55. Cosine theta is going to be negative 3 over root 55. Cosecant theta is going to be root 55 over negative 7. And then secant theta is going to be root 55 over negative 3. And that's it. Okay, so if you needed more help, I have office hours Thursday, Friday morning. All right, see you.